All right, guys, we're starting 7.5. Let's be quiet, please. Thank you. So if you have a graphing calculator, it might be a good idea to have it out. Not a big deal. But we're going to talk about some properties of logarithms, just like you have properties of exponents. Just to recap properties of exponents, because it's going to be closely tied to what we're doing today. And you don't have to write this stuff down, but it's going to be closely tied to what we're doing today. So if you guys were to see this, and again, you don't have to write this down, but if you were to see something like that, you have a to the x times a to the y. What would that equal if you simplified it? Good, exactly. And that should make sense, because if you have 2 cubed times 2 to the 4 power, that's 2 to the 7 power, right? Because if you were to multiply it out, that's 8 times 16, which is 128. If I do 2, 4, 8, 16, 32, 64, 128, yeah, that makes sense, right? What if you had this? What would you do? You subtract. If you have the same base, yeah, you subtract the exponents, right? We know this makes sense. For example, if I have like 2 to the 5th power or 2 squared, that's 2 cubed. That totally makes sense, because 2 to the 5th power is 32, 2 squared is 4. What's 32 divided by 4? 8. What's 2 cubed? 2, 4, 8, right? So that makes sense. And then lastly, this one, this is a common one as well. If you see this, what would you do? You multiply them, right? Again, you don't have to write stuff down. It's just all just old school review. You multiply, right? Because what if you have 2 squared then cubed? That's 2 to the 6th power. That makes sense, because if you have 4 cubed, that's 64. 2, 4, 8, 16, 32, 64. That makes sense, right? So these properties are going to be similar to the properties of logs. Very, very similar. So let's jump down to these 4 questions here. Log 2, log 3, log 6, log 9. And by the way, what's the base for each of these here? Good, thank you, Patrick. The base is 10, because it's common log. But I'm just gonna use a calculator, because I like, what's log base 10 of 2? I don't know. If anyone can actually do this to 5 decimal places right now, I'll give you an A for the whole semester without using a calculator. Yes, go ahead. What is it?
0.301.
5 decimal places.
25.
Okay, you're right with the first 3, by the way.
What?
Let's see if Patrick's gonna get an A for the semester.
What then?
Let's see.
Wait, what's the question?
What's log base 10 of 2?
Can I take a swing?
Sure, go ahead. Why not?
0.301.
And
1.
okay, so you have a 1% chance. Right. I already told you the first 2. That's not fair now.
0.3011 point.
All right, let's see. Are you right, Mr. Patrick?
I don't think I know.
You're wrong. Sorry. 0.30. Yeah. You get it? Anyway, but the point being is that that's not something you can do in your head easily, right? Like log base 2 of 8. I know that's 3, because 8 equals 2 cubed, right? We know this, right? So I know that's true. But anyway, let's use a calculator for these 4 here, because they're hard to do in our head. So let's see here. If I do log 2, and by the way, just the log button is base 10 in the calculator. You just hit log and then 2, that gives you base 10. So that's and we'll do the 3 decimal places. So 0.301. Let me repeat that for log 3. And if you have a calculator, great. If not, just copy what I have on the screen. That's totally fine. Let's repeat that. Let's do log 6. And you'll see why I chose these numbers in the first place. It'll make sense just a little bit. 0.778. And lastly, log 9. Oh yeah, you'd have to. But the purpose of this exercise is to show you how, when you combine logs, how the properties would work. I'm doing this to show you how the properties work. That's the whole purpose of this. Okay. Now let me lower the calculator, because it's a little distracting. Now here's a question. Now just take a step back, like, take a deep breath. Take a look what's happening here. For example, what if I were to add log 2 and log 3? 0.301 and 0.477. If I added these first 2 numbers, what would that be? be 0.778, which is log 6. Maybe it's a coincidence, maybe it's not, I don't know. What if you multiply this by 2? What if you multiply 0.477 by 2? What would you get when you get 0.94, 0.954? That's log 9. Interesting. What if I did trying to think of another one here. What if I did like log 6 minus log 3? 0.77 minus 0.477. I'll get 0.301, right? So there's some interesting things that are happening here. So what you're going to probably want to write down is like, what do we notice? When you add these two, log 2 plus log 3 is 0.301 plus 0.477, which of course is 0.778. Same as log 6, right? That's what we noticed. So apparently log 2 plus log 3 equals log 6. Okay. So here's the next question I have for you guys. Is there a formula we can use to generalize this situation? So apparently log 2 plus log 3 equals log 6. Well, what's 2 times 3?
6.
So do you have a formula, Lizzie? You think we could use?
AX.
Yeah. Yes. Good. Yes. What do you think?
Log X times log Y equals log XY.
You're close. It would be this: log X plus log Y equals log of X times Y. Exactly. Good. So this is right here is a property. I'm going to show you the properties on the next page, so you don't have to write this down. But log X plus log Y equals log of X times Y. They'll always be true. Kind of like when you have a to the X times a to the Y, it's a to the X plus Y. That's good. So this is the self-discovery we're going to work on. Like the next one here. What if I subtract log 6 and log 3? That was 0.778 minus, shouldn't have erased all that stuff. There we go, 0.477. 0.778, which equal 0.301, right? So what I notice, log 6 minus log 3 equals log 2. So there's a formula I can use for this. What's 6 divided by 3? That. So it's kind of like saying log X minus log Y. Yeah, totally. Yeah, that's something I'm noticing. If I subtract log 6 with log 3, I get 0.301, which is log 6 minus log 3 equals log 2. And 6 divided by 3 is 2, so it's not a coincidence. Excuse me. And then lastly, log 3 was 0.477. If I do 2 times 0.477, sorry, we heard just a little loud. Enjoy your soda or your drink. Okay. So you get 0.954. It's the same thing as saying this. Go ahead, Hugo. Not quite, but what's 3 squared? 9.
Sorry.
9, yeah. So you meant using an exponent. So there's also a property that says this: if you have x times log y is the same thing as saying log y to the x power. Same thing.
So X times log Y is log Y.
Exactly. Yes. Exactly. It's the same exact thing. It's kind of an interesting pun, but the x rolls along the log to get to the front, or rolls back. I don't know if that log rolling. I don't know. Okay, I'll stop. Yeah. What was that? No, not necessarily. No. Could be smaller, bigger than what y is. So here are the properties, guys. So those are the properties. You do have to memorize them, unfortunately. And the reason why is because you're gonna have to be using these often later in this chapter and in future classes. And so I would be doing a disservice if I gave them to you. So you do have to memorize them, and especially for those who are doing like ACT or SAT prep this summer and doing those tests in the fall. They don't have this. By the way, logs are not on the SAT, not on the SAT, but they are on the ACT. So they're on the ACT. You both. Well, I mean, you're going to use them with them. Well, no, but I mean, you're going to know how to write anyway. That helps. So, key thing though, note the bases for each log must be the same. Very important. They must be the same. So you have like log base bx, log base by. So I didn't have to common log it to ln, with the base 2, base 3. It doesn't matter. But the bottom line is that all the bases must be the same. Just like when you have 2 to the 2 cubed times 2 squared, we know it's 2 to the 5th power. But if I have like 3 to the 4 power times 5 to the 2nd power, can I combine those exponents? No, right? So you just work out each exponent, each power separately and multiply it. So in order to use these shortcuts or these properties, you have to have the same base for logs, just like for exponents. And notice how like this one here, there's a plus and a times, there's a minus and a divide, just like the exponents, right? And then here, you raise some of the power, you multiply n by log base bx, same thing. So same exact thing. One other rule you'll need to know, and then we'll do some examples. And wow, these notes are really old. This was before Schoology. We had a website called Argenda, so don't worry about it. That should be Schoology. Geesh, this is like 12 years. Wow, I can't believe that should say Schoology. My bad. These notes are dated for sure. Anyway, one more formula to talk about, and then we'll do some examples. The change of base formula is this. So this is how people did logs before the fancy calculators came around. So like when I was in high school, we didn't have the graph. Well, we did have graph calculators, but they aren't as advanced as the calculators you have now. So if I had to do like, for example, if I had to do log base 2,9, right? I don't know generally what number would that be like, or in between what two whole numbers will you expect log base 2,9 to be between? Log base 2,9? 2 to what power?
3 and 4.
Between 3 and 4, thank you, Matthew. So what's 2 cubed? No. Log base 2 of 9. So 2 to what power will get you 9?
Oh.
So 2 cubes 8, 2 to 4 is 16. So it's got to be in between those two. But the problem is that we don't know how to do this in our head, right? Because it's really. And again, if anyone wants an A for the whole semester, can anyone do this to 5 decimal places? Log base 2,9.
3 point.
You have 1 out of 100,000 chance.
3.10492.
So
3.10225.
just so you know, I haven't been paying attention to what you guys are saying, but
If I get it right, you have to believe me.
I wrote mine down.
no,
I
I
didn't get
didn't hear that.
I
So,
wonder.
okay, but anyway, it's 3.1699. Now, this change of base, just so you know, if you go out, if it math and then option A, it's there. Or if you hit alpha window, it's there. When I was in high school, about what, almost 30 years ago, when I took this class, 30 years ago, my calculator did not have this feature. I had to do this, log 9 divided by log 2. You get the same exact thing. This is called the change of base formula. Or if I did ln 9 divided by ln 2, I get the same thing. So the bottom line is this. You can write any log you want, but you have to change the base if you don't want to do the log you see right now. So it's a rule that always works. Your parents are probably roughly the same age as me, but so if you had grandparents who took math, like my parents in the 60s and 70s, they didn't even have these kind of, they had a thing called a slide rule where they actually had to use a ruler to look up all the values of the logs, and they had to combine the logs using decimals. So be grateful you have this technology. It makes it Now you have Desmos and other stuff. So anyway, let's do some problems. So these problems here are going to help you with 7.6. 7.6, we're going to solve log equations. We're going to do it on Friday. We're going to solve log equations. And you need to be able to combine logs to do that. So the stuff we do here is going to set the lay the groundwork for what we'll do Friday, or the foundation. And really, actually just have two examples. So it should be really easy, and then we'll just get to work after that. Just two examples, really easy test. So you're talking about the Masters golf? John Rahm was incredible. If anyone four putts the first hole and to win, that's pretty incredible.
That's all exactly right.
I had Rory McIlroy winning it, and so I was not happy.
I put $10.
I put in the pool for the Masters golf, but I don't know much. It's just fun to watch. Yeah, it's a tough sport. Yeah, and Koepka was looking good too. So okay, anyway, so let's talk math. When we finish, we'll talk golf and basketball rest of class. All right. So think of it this way: if log parentheses 3x4, right? Log parentheses 3x4. How would I break this apart? What would I do? I do log 3 plus or minus.
Plus.
Good, plus. Let me do this in green so it stands out. Log 3 plus
4.
Well, I'll do this first. And then what can I do with that exponent? Where could that go? What happens when you have a log of a power?
It becomes the multiple.
Yeah, exactly. Yes. Yes. Perfect. Got it. Thank you, Patrick.
Oh.
Yeah, there you go. That's it. That's fully expanded. That is a fully expanded form of that log. So if you have a product, 3x4 is multiplication. If you have a product, you could break it up like that. Totally break it up. And if you have a power, you can move the power to the front. Or sorry, the exponent to the front. Let's try another one. Okay. So think of it like this first. It's log base 6 of, I'm going to put a bracket here, 5 times x cubed divided by y. Gosh, it's hard to read. Let me do a new color here. Okay. So if you think about it, what can I do about the 5 and x cubed? How would I write that? So log base 6, 5, and what comes after that? Then plus.
Because when you want
Only x is raised to the power 3 though.
31.
31? No, I'm not done yet. I'm not done yet. I was answering this question. Hold on. Let me curl my L's. So here we go.
we have to curl our hair.
No, my handwriting stinks. That's all.
And that's
I just made it up. I'm trying random stuff on the screen. Just kidding. Let me back up a little bit. Let me back up. Let's back up here. Okay, so what's going on here? This is 5 times x cubed all over y. And you have a log base 6, right? So you could write like this first. Log base 6. I'm skipping steps. So let me do this first.
Isn't it 12 and 6, 5?
Minus base 6y. Okay, we're okay with that so far? Okay, good. So I broke apart the division as minus. Then next up, I got to break apart the 5x cubed. How do I do that? Plus log base 6 x3.
Wait, oh, you're breaking out the lower.
Because that's a product. So break it as an addition. 5 times x cubed is a multiplication. So you break it as addition.
Unless you just put it into.
Exactly, right. And then lastly, the 3 rolls to the front.
Why?
Because it's a power. That's one of the rules. Yeah,
So powers will.
totally. Yep. Because that's what we saw when we had like log 3, and we saw it was like 0.301, and then when 0.477, I multiplied it by 2. I got 0.954, right? So, yep, and there we go. That's fully expanded. So that's the final answer. Okay, so log base 6.5 plus 3 log base 6x minus log base 6y. Okay, any questions so far before we do example 2? Yeah, fine, okay.
I'm a little confused about
Mhm.
on the first step.
Yes.
Like under B, why did you add like a second log in front of a Y?
Oh, because what's happening is that you have a quotient. Whenever you have a division, because that's division,
Yeah,
we have something over something. You break it as 2 logs with a minus in between.
but like, where's the log coming from? Like, how you should add an extra?
So remember we had this property log base x minus log base y. It's up above on the page.
Yeah.
Is this? That's where it's coming from. It's coming from that. That's on the top of the page.
Is it because the first log is being distributed into the Y?
No, it's not distribution. It's just a property that we're using. It's not really distribution. I want to be careful about that. Like, remember on the first page, we have this. We have log base 6, which was 0.778. We have log 3, which is 0.4. Now I'm already forgetting. 0.477, right? And then we did log 6 minus log 3, which was 0.301, which is the same thing as log 2.
But like, if
Oh,
there was no log in front of the fraction, like,
well,
you
of course,
still be able to-
2 or y, and that's what it is.
so the first log has to be there to use
Of
that.
course, yeah.
Okay.
Because it's the same thing as saying this here.
Yeah.
Because 6 over 3 is 2.
All right.
Yeah, we're just applying the property. That's all we're doing. All right. Now, number 1, I'll be honest, I don't really care about. I care much more about 2. The reason why I care about 2, it's good to do 1 to see how the property works, but this I care more about. The reason why. Example 2 is way more important than example 1. And hold on, example 2. That's what I had to say. Because we need to condense logs often when solving log equations in section 7.6. And in your math classes beyond this one. So I was a little long-winded, but example 2 is way more important because we're going to have to do this often in the next section and other classes you do down the road. So I care more about that than example 1. So with that said, let's do the first part A. So we want to bring this into a single log. So when it says condense as a single log. That's it.
So if it's natural log, if we're condensing,
You keep natural log. Just write ln. You can write log base 2.7 if you want to, but all right. So where's that 3 go, by the way? Exponent. So it's log 9. Let me throw my logs again. Plus log 2 cubed. That's okay. I mean, you're a step ahead of me. That's all. I struggle with writing my 3s. Let's do this again. There we go.
Is that log? Is that same log?
That's log 9. Is that your question, Haley? Yeah. Okay. So now it's gonna be log. I know I'm gonna take a little. I'm just a little bit lengthy. Okay. How would I combine the first 2 logs, guys? Log of 9 times 8. What's 9 times 8?
72.
And what's 72? And then what do I do after this?
Divide.
Good. 72 divided by 3. Which is log of 24. When you get very good at this, you don't have to write all these steps, by the way. Like, I think most of you would know that 2 cubed is 8. Most of you know 9 times 2 is 72, and 72 divided by 3 is 24. I just wanted to show all the steps so you don't get lost in the process. But, this is what we do. Hey, good. Yeah, sure.
Oh, wait, never mind.
Okay.
I was- yeah.
Now, if you so desire, you could check your work in the calculator. If I did log 9, let's turn this guy on again. Log 9 plus 3 log 2 minus log 3. I get 1.38. And if I did log 24, I get the same thing. So you could always check your work using a calculator. Make sure you combine the logs correctly. Last one. Switch to green for a bit of contrast. And then you guys can do some classwork. Okay, so the 3 should roll to the back, right? So it's ln4 plus ln3 cubed minus ln12. Okay, what's 3 cubed, guys? Thank you, Charlie. And what's 4 times 27?
108.
Thank you, Patrick. And what's 108 divided by 12? Good. So we kind of did some arithmetic in our head, which is totally fine because you should be comfortable doing it in your head. But if you need 4 function calculator, it's totally fine. If you're doing stuff, but yeah, that makes sense. That's L9. Yep. And what was that? It's base E, but we don't have to show. And LN, it's just implied. Yeah, that's. Is anyone doing like the pre-ACT or anyone did that already? Yeah. So, you already did. Did you have any question like this on there? No. No. All right.
Actually, I didn't finish. I got through 40 and 60 problems, so they probably didn't.
Okay. No, I was curious.
I didn't see
Logs.
one
Okay.
or two.
All right. So the rest of the class. All right. So the rest of the class, I want you guys to work on the classwork. You guys should have the classwork problem sets. If not, I have extra copies. And then that's separate from homework. Homework is a separate thing. But the classwork's right here, 7.5. That's the solution key. I'm going to post the Schoology as well. So I don't think I've done so yet. No, we did something else. That was just another packet. Yeah, so you guys will be working on 7.5. And I do want you, even though there are some cumulative review problems, if you think about it, we have final exams in about 7 weeks from now. So, and trust me, when we get to middle of May and we start reviewing for finals, your eyes are going to bulge out of your heads when you see how much material there is. So I want to make sure you guys are at least doing some review right now.
Is our final for just the semester or 4 years?
It's just for the semester, but I mean, of course, you need to know like factoring and like system of equation. I mean, you got to know some of this, but any skills that were super specific to the first semester, no, of course I'm not going to. But actually, I don't remember those because I was on paternity leave, so I don't know. but yes, it's mainly focused on the spring. Let's go. I'm gonna try to do a week and a half or about 3 or 4 class meetings. Is that good or bad? Not enough. Well, that's why I'm doing some now. So I agree, it's not enough. So you guys working on this right now? 7.5 class. Lizzie, do you need? Yeah, I'll get your copies.
Oh,
No problem. That's why I made us copies. Don't lose it. Yeah, you got it. Yeah. Who else needs it? You do? Yeah. Who else needs you guys? Don't lose it. There you go.
Yes, we don't have.
If you need to. Yeah, it is. Okay. Tomorrow's fine. That's fine. Yeah.
Thank you.
Yeah. Do you want to email me too? Okay, yeah. I'll have it.
Thank you.
Okay, so we're working on 7.5, guys. I'm gonna write Amstel to work. Put the Amstel school as well. Yeah.
There was just, I don't know. It was like last year going through like the job.
Yeah.
Still on that.
I saw who it was. Phase 3.
He's legal.
Yep.
Okay.
Okay, let me post the answer to Schoology as well.
And then is that all you need to do?
That's it. All right, let me stop recording.